Okay, good. Thank you. All right, so the unit is on functions. So basically, you need to be sure that you can distinguish what is the difference between a relation and a function. That's one of the starting topics of the unit. A relation is man, my brain's not working this morning. A relation is a relationship between two different objects. Usually we call them X and Y. It could be in terms of a relation. It doesn't have to be something that can be graphed. It can be the colors of the scheme for school mascots being black and gold or red and white or blue and gold. You could have those kinds of relationships where you go through and what are the two color combinations, and it's not necessarily a graphable combination, but it is a relationship between the two colors. So that is a relation, but not a function. As we know functions, generally we think of functions as a relationship that is between something that can be graphed. But a relation is something that doesn't have to be graphed. So that's kind of one of the things that makes them different. We talk about domain and range when we talk about relations and functions. Be sure you know the difference between domain and range. Domain is the input, range is the output. Domain is the X, range is the Y. So you'd want to be able to identify what is the domain, what is the range. You might do that in a list if you had a set of ordered pairs, but you also want to be able to do that from the graph as well, or from the equations. And then we talked about the methods that we use to write domain and range. So we knew that there is a list that we use, but we also went back and looked at set notation. So that should be kind of a review from you from back when we did sets. And then we used interval notation. So for some of you, that may have been new, but that is a method of writing domain and range. In particular, if we were looking at the graph of a quadratic, and we wanted to talk about the domain for that particular quadratic. A quadratic, because it is extending on the x-axis forever, the domain for that would be all real numbers. So you could say x is a member of the all real numbers. That is one way to express the domain. If we were using interval notation, we would say it's from negative infinity to positive infinity. If we were talking about the range of that function, it is only from the point of the vertex up. So we would describe that using inequalities as saying that y is greater than or equal to, I think it's close to -2. In interval notation, we say that that is at -2 to positive infinity. It's going from this point up. Since it is equal to -2, we use a bracket. We never use a bracket with the infinity symbol. It is always a parenthesis. So that's just a quick rundown of using interval notation or using inequalities in our method. This is not really set notation, but it's the use of the inequalities as a description of domain and range. So that's some of examples of the types of problems that you worked with domain and range. In particular, the problems that you need to be concerned about with domain, you need to watch your square root problems. A square root problem has to have a positive number under the radical. So you have to know that in a square root problem that the domain has to be greater than or equal to 0. So be careful about your domain problems for square roots. Be sure that you remember in terms of writing domain that you remember to allow that to happen. That is a restriction that we have to think about for domain with square root functions. With rational functions, the domain cannot equal 0, so we have to be sure we allow for that restriction. You can never have 0 in the denominator, so we have to restrict 0 from being in the denominator. If you had a logarithmic function, it has to be greater than 0, so that would be a restriction that we would need to account for in looking at domain. If we were looking at ranges, some things that we would need to be concerned about would be, again, with the square root functions. Those are generally greater than or equal to 0 when we look at the range. When we look at quadratic functions, they generally start at being greater than or equal to 0. If they shift or have transformations, that's when this value does change. When you have an absolute value function, that starts out being greater than or equal to 0. When you have an exponential function, that range has to be greater than 0. It doesn't equal 0. If you have a rational function, again, it is not equal to 0 to begin with. This is when you look at the degree of the numerator and you compare it to the degree of the denominator. If the degree on top is less than, then it's not equal to 0. If they are equal, you make a ratio of the coefficients of the numerator over the denominator. If it's bigger on top, then there is no restriction. So rational function gets a little bit complicated. That's why you will not see much beyond this on your test. If you were taking a more advanced class, you would get into these other restrictions, but for our case, we will focus on the one where it's less than and just restricting 0. Any questions there on domain and ranges? We good on domain and range? We good with the interval notation? Everybody good there? So that's the big part to pick up on that first part of the unit. After that, you went into linear functions. So what do you need to be able to do with the linear function? You need to be able to find slope. Well, there's lots of ways to find slope. You find slope from 2 points. If you're going to find slope from 2 points, that means you need to know that formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So that is a formula you need to know. You either need to know it, memorize, or you need to have it written down so that you know where to go to look for it. If you find slope from the graph, you want to be able to either pick out 2 points from the graph and use the formula, or you want to be able to find rise over run from the graph. You know, you want to be able to find slope from the equation. The biggest thing about that is knowing that if you put the equation in the form where you solve for y, then the coefficient of the x term will give you the slope. The other things that you need to know about linear functions is the relationship of slope with parallel lines. When you have parallel lines, the slopes will be equal. And then with perpendicular lines, opposite reciprocals. A little trick here is the product of the slope equals 1. So if you want to tell if the products or if the slopes are for perpendicular lines and you multiplied them together, you would get 1. Excuse me, not 1, -1. You get that right. So that's one of the first things that you dealt with linear functions, was dealing with slope. So all of these things dealt with slope, being able to find slope from 2 points using the formula, finding slope from a graph, knowing rise over run, finding slope from the equation, solving for y, and knowing slope is the coefficient in front of x, the relationship of slope with parallel lines, the relationship of slope with perpendicular lines being opposite reciprocals, or that the product of the two slopes will give you -1. Next, with linear functions, you wanted to recognize that your equations come in many forms. We already talked about the slope-intercept form. Y equals mx plus b. There is also standard form, where you have ax plus by equals c. There is general form, ax plus by plus c equals 0. There's not a great deal of difference between general and standard. It's just the position of the constant value, whether everything's on one side set equal to 0 or whether it's not. And then there is point slope form. You should be able to use the equation of a linear function in any of these forms and be able to go back and forth from any of those forms. Remember about the concept of slope, being able to tell used to describe lines as rising, falling, as a horizontal line, as a vertical line. If you're rising, you have positive slope. If you're falling, you have negative slope. If you're horizontal, you have 0 slope. And if you're vertical, you have undefined slope. Now, keep in mind, 0 slope is not no slope. The undefined would be the no slope. With the equations, you want to be able to find equations of a line. You may be given 2 points. You may be given the graph. You may be given a point and slope. You may be given various information, but then you want to be able to write the equation of a line. So those are skills that you would want to be able to do for the test. And then you want to be able to use all of this information in an application problem. Any questions about the linear functions? So those are things that you should be able to do for the linear functions for the test. All right, if there's no questions, we'll move on. The last one that you studied in functions were the quadratics. With the quadratics, we talked about the symmetry in the quadratics. We talked about the line of symmetry. You want to be able to find that line of symmetry. If you know what the vertex point is, you should be able to find the line of symmetry. So we often talk about the vertex point being that point HK or XY, depending on how you want to think of that. And so the line of symmetry is the X value of the vertex point. X equals whatever the H is. So the line of symmetry is an equation. X equals whatever the value of the X is in your vertex point. You also learned about equation formats with your quadratics, where you had the vertex format. In the vertex format, you can pick out the vertex, H and K, when it's in that format. You have general form. And you have standard form. You want to be able to identify whether a quadratic opens up or down. using the terms concave up or concave down. And that has to do with the sign of the leading coefficient. Or the A value, whether it's the A in the general and the standard form or the A in the vertex form, it's the same A. If it's positive, it's going to open up.
Oh.
And if it's negative, it's going to open down. You want to be able to identify transformations with the quadratics, particularly using the vertex form. Remember that the H value tells us how it shifts left or right. The K value tells us how it shifts up or down. The A value tells us how it shrinks or stretches. A positive or negative A tells us whether it reflects the x-axis or not. So you want to be able to identify those types of transformations. You want to be able to change from one equation format to the other. And you want to be able to use that technique of x equals negative b over 2a to help you go from general to vertex form. You want to be able to find the intercepts, whether they're x or y, intercepts. In particular, if you're finding x-intercepts, you want to remember your factoring rules. You may have to factor. If you can't factor, you use the quadratic formula. And that would be x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So that's another formula that you would want to have written down nearby to have during the test. And then you'd want to be able to use any of these concepts with application problems involving quadratics.